So welcome everyone. My name is Philip and I'm joined here by Jane. We're both working in the EMEA region to represent Tagira, which is a company, as you probably know, behind Calico, along with the community. Topic of today will be egress access controls, basically meaning that we'll focus on how we can actually limit, control what pod or user can actually access resources out of a pod. So that wording egress. So if you want to check me out, feel free to go on Twitter. I like to post technical stuff on Twitter and on LinkedIn, so feel free to check it out. But today we're going to talk about Calico. So what is Calico? Calico is a community-based effort supported by Tagira. And we actually are in the business of open source networking, as well as open source network security. So briefly, Tagira offers what we know as a CNI, a container network interface solution, which serves as a plugin for Kubernetes, OpenShift, and much more. On top of that networking solution, we actually implement a networking security solution, which is probably known as network security policies or Calico security policies. And that's the main topic of today. So I typically forget it, so I would like to invite you to the upcoming events. There are a few of them around multiple topics. Please check out tagira.io/events. You can sign up just as you did for this one and join them, or actually go to our YouTube channel where we record everything that is been done in the past. So feel free to check it out. Of course, we prefer the live versions, so do not hesitate to ask questions or leave a comment in the chat if you want. If you want to know more about Project Calico, there's a lot of documentation, so I urge you to go to projectcalico.org or docs.projectcalico.org. You can find all the information you need about setting up, configuring, examples, and so on and so forth. So a good place to start if you're interested in Project Calico. Of course, you can find us on Twitter, on GitHub. Of course, a very active community is Slack. So subscribe to our Slack channel and you will see that whatever question you have about the open source solution, that will be answered pretty quickly. So I really encourage you to do so. So Calico itself, why would you choose Calico? Because it's highly scalable, meaning that you can build really large and very large clusters. I'm often confronted with the question, yeah, but if I only have 2-3 nodes, why would I use Calico and not Flannel or something else? Well, think about it. If you build larger clusters, multi-data center, hybrid cloud type of clusters, highly scalable networking and flexibility is a big must. That's also why we are quite often mentioned as the most widely distributed networking solution. If you check LinkedIn, you will see that we are by far the largest used CNI. We implement network security policies, as Arvind mentioned, but we also have the ability to use the Calico network security extensions, which is a more advanced way of doing it, a way more flexible way of doing networking security policies. And it's renowned because it's way better. Just think about the fact that Microsoft AKS is using it, EKS, GKE has an option to use it, IBM Cloud can use it. So the extended feature set of Calico is pretty interesting, and we'll discuss a few of these topics during the presentation. We always remember or refer to Calico as a container-based solution, but you can actually use Calico networking in containers, but also for VMs that you might have in your cloud environment, as well as for securing the Kubernetes hosts themselves, which is a pretty important aspect of security, of course. Calico can be found in a lot of places. So as I already mentioned, you can find Calico open source as well as the enterprise editions for that matter. In the largest public managed clouds. Of course, you can use Calico also in on-premise scenarios where it's native Kubernetes, or you use Docker Enterprise, which is now Marintas or OpenShift. You can actually use it together with other orchestration tools. It works perfectly. For example, Rancher. I think there is a Rancher Calico webinar coming up this week. Otherwise, check YouTube. I think we did one a few weeks back in EMEA also, so feel free to check it out. Now, when you look at this, and I had a pretty cool discussion with a customer last week, is that, yeah, how many clusters do customers or prospects actually use? Well, we might perhaps wrongly think of using one EKS cluster or one AKS cluster, for example. But the truth is that in the initial phase, it might be more interesting to have multiple small clusters, while afterwards you might migrate to, instead of a lot of small clusters, to fewer, more complex clusters. But the truth is, it gets very hard to manage if you have to manage it all on a cluster per cluster basis, implement microsegmentation and so on and so forth, multi-cluster management, as well as a single pane of glass inside of all your clusters really becomes a must. If you don't have logging, if you don't have visibility and so on and so forth, it can be a really daunting task. Basically troubleshoot it, but even worse, check what is actually happening inside of the clusters. So that's why Calico Enterprise works seamlessly together with the cloud environments, for example, and orchestration tools like, for example, Rancher and other ones. So I'm not saying one is better than the other, for sure not. So check out Calico Enterprise if you want to see real value of what it can offer if you have multiple clusters, of course. So let's jump into the nitty-gritty techie details. So the entire problem lies really down deep in Kubernetes. Why do we need all these, at first look, complicated policies to implement and to control the traffic flowing out and in our clusters? Well, the underlying problem that we need to solve is that Kubernetes network model was designed to be a flat network. No matter where you look at Kubernetes networking, whether it's public or private on-premise, the whole design is that it is one big flat network, which is typically referred to as the pod sider. So if you install Kubernetes, for example, with kubeadmin, you have to specify a network. Well, Kubernetes and the CNI will make sure that every pod gets an IP address out of that pod sider range. One of the design goals is that every pod should be able to talk to every pod in Kubernetes, which basically means there is no security, there is no segmentation, there is nothing that prevents one pod from talking to other pods. Now, we might solve that. We know how we can actually prevent IP addresses from talking to IP addresses by what we've learned with IP tables and network firewalls in the past. The big problem is that in Kubernetes, everything is dynamic in nature. That means that if a pod is started, it gets an IP address out of a pool of IP addresses. When the pod is actually terminated or killed or is crashed or moved to another node, well, it probably will change IP address. So there is no real good way or deterministic way, as you might say, to actually identify a pod by an IP address. Yeah. So we need to find other solutions to actually identify pods in a correct and unique way. We'll revert to labels, as you will see. Last but not least, very often when you install a CNI somewhere on a cluster, and it really depends on where you install it, but every CNI tends to work differently. But quite often, when a pod connects to the outside of the cluster, for example, to an API like Slack or Twilio or whatever, yeah, the IP addresses of the pods are typically not routable outside of the cluster. Now, I know that you can solve that with Calico, and Calico has an option to do that. But let's say in general, yeah, once a pod leaves the cluster, it's actually address translated behind the IP address of a node. That means that outside of the clusters, it's even harder to identify a pod or the originator of a request, for example, at the edge gateways or firewalls. So we need to have a solution for that, and the solution can be found, of course, within network security policies. This is a small slide talking about a CNI, but also keep in mind that addresses are assigned out of a pool. The intelligence by which we assign these IP addresses, the heart behind all this is the IPAM, and so the IP address management component. If you tend to use Calico, you will know that we have a very flexible and very intelligent IP address management system compared to other solutions that just take out of a flat text file an IP address. So if you're using Calico open source or enterprise, you can also benefit from the address management capabilities of Calico. That's what you typically hear as an IP pool or an IP block inside of Calico. So moving to Calico open source is already a good decision for these two reasons. Now, how do we identify pods? Yeah, as I mentioned, we cannot do it based on the IP address. So luckily, we have labels inside of Kubernetes. And a label, when I actually started out with Kubernetes and Docker, I had a problem understanding it, but label is basically just a name that you assign to a pod. You can say this pod has a label. For example, allow internet equals true. It can be anything. Yeah. And based on that label, you can, of course, select the pods. So we're going to assign labels or use the default labels, of course, if there is a pod or a deployment. Based on that label, we can actually select our pods. That's how deployments work. This is how services works in Kubernetes. This is how pod security works in Kubernetes and so on. So it's a very important concept inside of Kubernetes. It's declarative, which means that you can actually describe inside of a YAML file, unluckily, actually what the state of your security needs to be. So you can actually say these pods are allowed to connect to the internet. When you actually create or do kubectl apply, you actually make a declarative statement saying that these pods, no matter where they are, no matter when they are started, need to be applied with this and this and this security policy, which also is, of course, why it can be dynamic. Labels are not dynamic, so for that reason. Now, if we want to start out, we have to look at essentially how you actually deploy something, because that's the key reason why this label system works and why this label system is so flexible. So if you think I'm just using a very small deployment here, as you can see, it's a deployment. I actually have 3 replicas using kubectl scale. I can actually increase the number of replicas or decrease the number of replicas. You can use auto scaling for pods. So there are plenty of reasons why the number of pods might change over time. This deployment is actually using a container Nginx, nothing special. And as you can see, we apply or attach a label called app:/Nginx. Why do we need that label? First of all, we need that to apply our security policies, but actually deployment for the replica set, who is making sure there are always 3 members in this deployment, so 3 Nginx pods, well, it's also based on the label. So as long as there are 3 pods with a label app=Nginx, we actually fulfill the declarative statement we just made. So keep in mind the labels. In this case, they are used to make sure there are always 3 running, but in the next, we'll use that exact same label, or one that we add, of course, in the deployment to create our security policies. Now, the network policies, So the network policies themselves, there is an important aspect to network policies. There are actually 2 types of network policies. First of all, what you need to know is when we talk about, and I stress it, Kubernetes network policies, you can actually see that by the fact there's an API called networking-kubernetes.io. Is always applied in a namespace. You can specify the namespace inside of the network policy. That actually means that the set of rules that are following here will only be applied, in this case, in the namespace called my namespace. This exact behavior can be obtained by Calico network policies. But Calico network policies, they have the ability to be global. So in Kubernetes, it's always on a per namespace. Next, we have to basically tell our API on which pods we actually want to apply a set of rules. And as you can see, this is done by the pod selector statement here. So it will actually say apply the rules on every label, on every pod with the label role DB. So in this case, only the DB pods. The specification also includes what we call ingress rules. An ingress rule, as you can see the arrow, is basically to be interpreted for connections or flows that come into a pod. Yeah. As well as you might have an egress block in your statement here, which will actually control connections or flows that can originate from these pods. Yeah. So there's always an ingress part, there's always an egress part. Although a network policy resource can omit egress or ingress, so if you do not specify an ingress block, yeah, for example, no rules will be applied. If you don't specify an egress block, no rules are applied. The default behavior in Kubernetes and in Calico is that if no rule is applied to a pod, let me specify, if no policy is applied to a pod, so if it's not selected by a network policy, the behavior is allow all. So if you do not specify anything, at this point, all communications can flow freely in and out. Once a network policy is applied to a pod, like in this case, only pods with role DB, then it is actually being enforced. So in this case, nothing else than connections coming in to frontend are allowed, and only connections to this network block are allowed. So be careful with that. If nothing is applied, you can actually do whatever you want. The moment a pod is selected by a network policy, the specified rules do apply. That's it. Okay. Now, in this case, once you deploy this, it's clear that only the database pods, I assume, are protected. There are no rules applied on front-end pods, no rules applied on the helper pods. The only reason the helper pod cannot connect, for example, to the RollDB pods is because there is a security policy on RollDB that prevents them from talking. Yeah? So be careful with it. Now, to make it a little bit more clear, in this case, and it's a little bit out of scope of this presentation, we actually created, a network policy in my namespace. So it's only applicable there. It actually applies only to the blue pods. And we actually say that we only allow connections to come in from roll frontend, so the green ones, to a specific port 6379. Yeah. So once you enforce this, only the connection between roll frontend and roll DB can happen. The fact nothing allows roll helper to communicate, roll helper will not be allowed into roll DB. It doesn't mean that roll helper cannot do something. It can connect to probably anything it wants, but at RollDB side, we will deny the connection. So there's a subtle difference. Everything happens here on the RollDB. If you think about it, the IP table rules are configured, let's say, on the RollDB pods. So that's important. Now, the topic of today, and it's a little bit more complicated, these scenarios, because you might do things that do not work out that well. So that's why we spent some time on it. So another way compared to ingress is egress. Egress means that you'll control the flows that actually originate from pods. So in this scenario, we basically say that, for example, we're going to apply everything in namespace default. Yeah? The rules are applied on the pod selector, which is in this case color red. As I mentioned before, that label that you specify when you deploy that pod can be anything. And in this case, we see that there is only an egress block. So that egress block that says that pods with color red can only connect to, in this case, the CIDR, which is mentioned here. And that's the only thing that color red can originate. It's kind of tricky because if you would apply this rule, it will do exactly as it says. But think about Kubernetes is very dependent on DNS. So always think, if you copy paste these kinds of rules, think about the fact that your pods typically do not connect to IP addresses, but connect to a host name. And to have host name resolution, you need to have DNS. So always think about it. It's a frequently made mistake. So ingress, egress, mind the difference. Now, in this scenario here, as you can see, we actually controlled the egress part of color red. As you can see, there is no ingress specified. That means there is no ingress rules applied. Yeah. It basically means that all the connections flowing into color red are still allowed. So if there is no ingress specification, there are no ingress rules, meaning that the default behavior is allow all. If I would have mentioned here ingress colon with nothing behind it, everything would have blocked. So be very careful with it, because actually the way to start out correctly is to actually always create a default deny rule. And a default deny rule is a particular rule, because as you might have seen or noticed already, is that Kubernetes doesn't have a concept of allow or deny or log or whatever. So Kubernetes can only say this is allowed, and what is not allowed is implicitly blocked. So you cannot create a deny rule, except in this very specific case. So if we analyze this rule, we can actually see that the pod selector is still on my namespace. So it's only applicable per namespace, and you have to do this on every namespace. Match labels with the curly braces basically means select all labels, so select all pods in this scenario. And then we apply an ingress block and an egress block without any rules. So it actually means on all the pods, implement no rule, which will have the effect that all the communications inside of this namespace will be blocked. So the good way to start out is actually, if you have the guts at that moment, to basically create a default deny rule. You're sure that no communication in or out that namespace can happen. And then add rules of type egress as before, or ingress for the sake, to actually fine tune and granularly allow the communications you actually intend to allow. Okay, that's what we will try to do in the demo. I see there are a few questions that popped up. I cannot see them in the chat. Okay. Okay. So let me go back here. Okay. Now, Calico also implements a mechanism that says that you can actually create network sets. Network sets are a Calico resource, and the Calico resource basically says that you can actually create a list of IP subnets or IP hosts or IP networks or CIDRs, and which basically allows you to manage a list or a network set of IP addresses. Once you create that network set resource, which is, as I mentioned, a Calico set, you can also apply a label to it. As you can see, there is a label called roledb. That label can be referenced inside of network policies. So that means that you can actually maintain a list of specific APIs, of services networks or VMs somewhere in your cloud, and then essentially manage the access towards these VMs. Calico uses network sets. You can use it in the open source edition, but you can, of course, also use Calico Enterprise, which is also the basis of what we call thread feeds. So what Calico Enterprise does is that it can actually import lists of IP addresses and convert them into network sets in a dynamic way. Network sets can be namespaced, as in Kubernetes the case is typically, but they can also have a global nature. That means that you can create global network sets so that you can actually say, okay, access to these and these and these bad known actors, for example, yeah, are not allowed from any namespace. So the global concept in Calico is pretty intriguing, and global network sets is also something that are actually allowed in the open source editions. This is how you would do this. So you can basically create a network set, which is a list of IP addresses of service I own. And this is actually a very similar way in how you actually apply these rules. Now, as I mentioned in the beginning, controlling access for internet, for example, can be very challenging. Once you have pods and they try to access, for example, the internet or another service inside of your cloud, they will actually try to reach the internet through routing, and IP tables will make sure that in most cases, the pod communication is actually address translated on the node IP address. That actually means that the router or the firewall that actually will control the access, which is very often out of control of those who manage the Kubernetes part, will not see the IP address of the pod, and the router or the firewall will have honestly no clue who is actually trying to reach the internet. The only thing it will see is actually communication that originates from one or the other node. So it's very hard at this outer firewall layer to control access. And I think we all will agree that this is, of course, an important thing to do. So the solution here is that, or you use routable IP addresses. It's one case, but still your firewall will know who is who in Kubernetes. Yeah. So the trick here to solve this is that we should actually implement two layers of security. One very fine-grained layer of security inside of your Kubernetes cluster, together with Calico policies, for example. And second, maybe a dynamic rule set inside of your firewall based on what the Kubernetes cluster is telling the firewall. And that is exactly what Calico firewall integration or Calico Enterprise firewall integration is doing. It can actually configure the firewall saying that, okay, pod 1 and 2 are allowed to connect to the internet, so it will automatically populate the firewall with, in worst case scenario, node 1 and node 2 IP addresses, or with the IP addresses of the pod if everything is routable. So the firewall integration is a pretty cool feature that you can actually implement with Calico Enterprise. Yeah. Another way to do that, as I mentioned, is by IP pools per namespace. As I mentioned in the beginning, Calico has IPAM and what is called IP pools. You might actually try to use IP pools that are accessible to the internet and IP pools which are blocked. So using the IPAM, Calico might help you on that front also. And then last but not least, Calico Enterprise also implements what is called an egress gateway, because whatever you actually do, whether you use IP pools per namespace or you use standard firewall integration, in 90% of the cases, you're always allowing a node accessing the internet or not, yeah, in a dynamic way. The egress gateway connectivity solution that Calico Enterprise implements basically allows you to tell Calico that specific pods, for example, based on a label, yeah, are tunneled to what is called an egress gateway. So all the communications that are intended to leave the Kubernetes clusters are kind of tunneled to an egress gateway. So the only thing that is accessing the internet or the external world in Kubernetes is the egress gateway. And that egress gateway can be configured with a specific IP pool. So what you get in return is that at the outer firewall layer, you can actually say that if app 1 is accessing the internet, no matter where it lives in the Kubernetes cluster, on whatever node it actually lives in the Kubernetes cluster, yeah, it will always leave the cluster with a specific IP or a specific range of IP addresses. So it becomes way more easy in the outer space or at the edge to actually specify who is allowed to leave the cluster. So egress gateway, there's a lot of things happening around it, and it's something which catches the attention of more complex clusters and how to manage the egress flows. This is the firewall integration. So if you want to integrate it, this is a 40 gate example. So Tagira offers what is called a Tagira firewall controller. The Tagira controller basically will analyze your Kubernetes environment, check what nodes host which pods. Based on that information, it will automatically configure a 40 gate address group inside of the firewall. So it's pretty easy to set up. Check docs.tagira.io and you will see that it's pretty easy to do. We launched a few new things recently. If you are interested, you can sign up. The first people are, by the way, certified for the Calico certification. Just go to this link or search for free certified Calico training. You can sign up. And of course, once you get access, you can actually do about a 2-day, 3-day training, depending on how much time you can spend on it, which will guide you through all the basics and advanced stuff of Calico and certificate of completion afterwards. So if you're interested, sign up, it's free. Another thing I want to point out and bring to your attention is that our CTO, together with his technical team, launched the Tagira ebook about networking. It goes really deep into the technicalities of CNIs and IP address management and so on and so forth. So head out to this link and you can actually download the ebook for free. It's very good reference on how networking actually works inside of Kubernetes. And last but not least, and then we're through the slides, if you're interested in seeing Calico Enterprise working or try it out, please go to tagira.io/trial. You can sign up, and there are two options as of a few weeks back. One is that you actually host it, that we host everything for you. You can simply connect a demo or test cluster to a managed environment, so you don't have to be bothered with setting up the entire management plane. Or you can actually ask for a license so that you can set up on your own in your own environment. So it's up to you. But if you want to basically quickly test it and you have a small, an open source cluster, you can actually hook it up to the management portal and start experiencing all the cool stuff Enterprise is doing. Okay. So let me switch.
Billy, we have a couple of questions if you want to take them while you're swapping over in the Q&A.
Yeah, so I'll try to I have already a running Kubernetes cluster, and if the network policy is applied, deny ingress, and will the policy be in action? Yes, we will see that. So the moment you actually apply the network policy, it's effective immediately. And so that's a very good question, because it can be painful if you make a mistake. On a side note here, Calico Enterprise has a preview feature as well as a staging feature, where you can basically create your policies, apply them, see how they behave, and then promote them to production or enforcement. Yeah. Can you use unused network policies? That's another very good remark. I can share a link with you how you would do it with kubectl and JSON query, which is pretty daunting task. Calico Enterprise has the option, I can show it if you remind me, where you can actually see which policies aren't used, which pods are in which policy, and so on and so forth. So I'll try to show that immediately to the in the demo. So let me clean up my screen here and head out to this. So I put the examples of this demo into this GitHub repo. Let's see if I can put it in the chat box, Q&A, or the chat box. No. So this is the link, so that I have it. Okay. So I put a few examples here in. So I have a cluster here in running in AWS, but it doesn't matter. It's just consider it a network policy, sorry, a Kubernetes cluster that is simply on bare metal or in VMs or even Docker for Mac. So what we will do to test out most of the things is that let's create a simple namespace here for my demo app, and let's run a pod here. So it just, you can use anything if you use something of your own or NetShoot, whatever. This is my debugging pod. And we're going to run it in this namespace, execute bash, and I already applied a label. So that's a way to do labels. But for the first examples, this is not important. So if everything works out well, I should have a bash prompt somewhere on my Kubernetes cluster. So essentially, I can connect to anything. Let's use this .io. And as you can see, we got connectivity. If there would be running something on my cluster, you would be able to connect to this pod from at least inside of the cluster. So as I mentioned, we're going to apply a deny all egress pod. Now, for the sake of this demo, and what I mentioned is, you see there is only egress in this case, but if you specify ingress, but the particularity is that I actually excluded UDP port 53, because if you create immediately a deny all, which will work, DNS will not work anymore. So if you would try something like curl tagira.io, it doesn't work anymore. So if we apply this, we will actually see that this is just to create a file. So if I'm going to apply this default deny egress rule. Yeah, it's created. You see my pod is still open. So if I didn't make any mistakes and I would do curl tagera.io, I'm actually blocked. And to be more specific, the TCP connection to port 80 in this case is blocked because of the network policies. If you would dig deeper into it and you would, for example, do tagera.io and I didn't make any mistake, you would see that it still tries to resolve DNS names. If I take another DNS name, you would actually see that it should work also. Yeah. So DNS is allowed as specified in my network policy, but the TCP connection to the websites is actually blocked. Be careful with it. It's a simple but important troubleshooting step. If you have issues, see whether DNS works, because if DNS doesn't work, you would never go to the phase of initiating a TCP connection, of course. So let's solve the problem of having access to the internet. So I'm going to create a network policy that will allow port 80 and port 443 to be accessible. Please note that there is a label. So this label is only applied on pods with this label. As you mentioned in the beginning, I already applied this label here. So that pod has that label. So if we're going to create that rule here, so just create a file. I do it like this because there's a shorter way, but it allows you to modify the files afterwards if you want to play around. So right now I've actually created the egress rules for port 80 and 443. So if everything works fine, and I would connect to tagera.io, so you remember DNS worked, but TCP connection didn't work, I can actually do this and spend some time on it this morning. For example, if you want to follow the redirects, I think if you're lucky, you can actually follow it through the HTTPS example. So as you can see, we have DNS allowed in one rule set. We have port 80 and 443 allowed in another rule set. All these examples up to now do work inside of Calico open source. Yeah. But you have to have Calico open source, not Kubernetes. Yeah. So in the next example, we're going to create a network set. So as you can see, the network set, we're going to actually create a network set that contains these two IP addresses. Feel free to change it. These are two IP addresses I control. These are two of my web servers, so that's why I use them. So let's create a network set. Here, network set is created. Sorry, the file is created. We're going to create the resource. So at this moment, there is an object in Kubernetes of kind network set that holds these two IP addresses. So you can update that list with kubectl apply. Now we're going to create a rule that will use it. So we'll see on the pods that with this label, if somebody tries to connect to role equals API, and if you see the network set is identified by label role API. So once we're going to create this rule, this file first, and we're going to apply this, basically means there is a deny rule in place for IP addresses listed in this network set. So the pod is still open here. Yeah. So these IP addresses are the IP addresses of radar hack. So if I go to radarhack.com, we'll actually see that it is blocked because of the fact that the IP address to which this resolves is in that list. So if I'm not mistaken, if we would go to tagera.io, tagera.io would still work. Okay. Now, this might become complex, so you can analyze all this stuff with kubectl and so on and so forth. Of course, a more convenient way is to actually look inside of Calico Enterprise. And Calico Enterprise, for example, first of all, will show you the network sets. There should be one here. I think I'm locked out. No, it took a while. So where is it? Network set API access, as you can see, it's over here. So it's visualized. You can even edit the files out of the UI. I created the network set. Afterwards, of course, I created a rule that referenced it. So if I go to policies and I actually switch to graphical mode, you will actually see that there is a rule somewhere around here, external API access. You can actually see that one pod is selected. So if you click on it, you can actually see that the pod that is selected is essentially the pod that I started out. You can see the label here. So cool thing about this is that you can actually see where it's applied. You can actually also see whether egress traffic is flowing or not if you check out the statistics. And of course, you can visualize the rule set in UI. You can use the UI to build rules and then finally download the rule, and you would actually see the YAML. So if you copy paste this, you can actually fairly easily, through means of automation, deploy these rule sets. Okay. Now, let's go a small step further. So in the next example is an example I created a global Calico network set. Again, this is still possible on the open source. So I'm going to create this and apply this. And the example here, I modified it in order to create an example that says, like, if my pod has an allow internet egress label, then I would allow it access to the internet. So if we apply this, we're actually doing the reverse of what we just did. That's why this is a demo. And if we apply all this, we can actually go back to testing. So if I would test here, you would actually need to see that if I use scroll and I go to this list of IP addresses, it still works. Yeah. If I would exit the pod and I would go into the pod and I would remove the label or put it to something else, false, for example. And if my pod is started again and I would do curl.com, you would actually see that it doesn't work. Now you might say, yeah, but what's the purpose? Because I can actually put any type of label on it. So if I want to evade this, I can just add a label. That's true. But the good news is that Calico also supports actually labeling of namespaces. So you might say that a specific namespace, like in this case, my demo app has a label allow internet egress through, and that can be controlled by RBAC. So if a higher authority says this namespace is allowed to go to the internet. You can set it. If they don't want it or they don't put any label, it will be forbidden anyhow. Okay. I just exited the spot for the reason I had to remove the label. Yeah. So, but as you can see through the entire demo, I was in exactly the same pot. Now, last, and this is a Calico Enterprise feature to show it, because we're using network sets. In these network sets, I refer to IP addresses. You all know that IP addresses tend to change, or websites or APIs might have global load balancing enabled, so meaning that you're not sure to control which IP addresses to connect to. So to show you this feature, I'm going to first of all delete the network policies we just created, because otherwise I get access anyhow. So I can actually create a network policy based on DNS names, domain names. So once I apply this, there is a rule in place that will actually only allow access to hosts that are actually resolving to this domain. So if I would start my pod back here, and if I would do the proof of the podding, I would do curl. You see, it works. If I'm not mistaken, but I didn't test it, there is a www2 server also. It works. Yeah, everything underneath this domain name will work. If I would use something else than this domain, and I would do, for example, curl.io, it doesn't work anymore. So the cool thing about this is that you can do it on domain names, and you can specify specific allow rules for specific domain names. So if you have pods in your Kubernetes cluster that need to connect to the internet to specific APIs, for example, Twilio or Slack or something like this, well, based on the domain name, you can actually allow access. Yeah. This actually analyzes DNS resolving that happens inside of the pod. So once a pod does a DNS lookup for a specific hostname in its domain, well, based on the results, it will actually open the flow to the internet for the time to live specified in DNS. Yeah. All this information, of course, if you want to troubleshoot it, is also available inside of Enterprise. Don't have the time for it, but everything that happens in the Kubernetes cluster is actually logged. So you can scroll through the logs, look up all the DNS requests. So all the flows, DNS, TCP flows, and so on and so forth are actually triggered, and it can be reviewed. And if you appreciate more an interactive way of analyzing your flows, you can actually use the flow visualizer inside of Tagira and actually click through the flows. So for example, if we would look at the namespace we were playing with, we can actually zoom in on it, put labels, and we can actually see the flows that happened. The red flashing ones are actually the connections I did that denied it, yeah, and so on and so forth. So it's a way more intuitive and interactive way of looking what's happening inside of your cluster. If there are any questions, I'll look into them. If not, I will thank you for your presence. I hope it was interesting. And as always, if you think about topics or fields of interest that are important to you, please drop us a message, and we'll see in one of the future webinars if we can address one of these topics.